Morning, everyone. We're gonna start shortly around 8 o'clock. All right, so just relax and get ready. And around 8 o'clock, I will start sharply. All right. Morning, Chris. All right, let me just shut off my music and get ready to start. Um, so I hope everyone, I think you are doing okay. I think this is probably our coming to the third weeks of online teaching. So hanging in there, guys. I think from whatever the task force, the government task force, they predicted that I think this week and next week is gonna be the peak. So hopefully that I think we are doing a good job not going out and trying to stop whatever these I think this disease. I think even though many of us would not have some impact, but I think directly or indirectly, I think it will impact especially elderly, because from whatever the record, if anyone older than 65, I think 90 something percent, I think they're gonna pass. So I think just hanging in there so that we can go back to whatever normal life faster. But anyhow, let's start. I mean, before we start, I want to talk about our term papers, okay? And also, if you guys, good morning, all, Ryan, Jack, and Jake. If I mean, when you listen to my this live broadcast, if there's some issue, like for example, the audio is not clear, the picture has some issue or whatnot, I'll try my best. In fact, this week I have maybe $1,000 left on my professor budget on money. So I'm spend all of them on the whatever this multimedia, the audio. So I ordered the new microphone that potentially maybe will produce a clearer kind of audio. Also, I think when you start, I mean, when you see here, I might kind of look down a bit because of um, I think I'm using my notebook, and you can see that. Let me just switch, and before we start our lecture here, this is my stand that I'm improvise using the box. So I'm buying some new stand with the height adjustable and all those. So I think hopefully I think we're getting improved in terms of better experience for both you and I, because if I can deliver in more comfortable way, then our communication or the dissemination may not be effective. But anyway, I think um, I would say that I think now, even though I wish we go back to the normal life, but this challenge also, this crisis brings some opportunities. So I learned quite a bit that I thought that I mean in the past 30 something year I'm about retiring. I thought that I know a lot of stuff, but in fact there are plenty of things that I have not learned. But anyhow, I think last time we before we switched to CPU scheduling, we stop at this point. I also has upload the the recent PowerPoint to the Moodle. So just look it up there. All right. Also, Carrick has asked or request I put more detail in terms of presentation. So I already posted there, but I'm gonna talk a little more in detail and then showing what are the topic that has been chosen by you guys. And then I'll show you there are some very popular topics that maybe perhaps, I mean, some of you guys are interested in the same area, just pivot to slightly different. It might show bring some more interesting kind of knowledge to share among all of us here. But before we start, let me start talking about the quiz number two. Good morning, everyone. Okay, I think a lot of people say hi. I think um, I look at the quiz in terms of the scoring. I think it's quite pretty good. I think we have majority. I think you all get 10 point, which I think perfect score, which is good. I'm hoping, in fact, I'm hoping that by default, everyone should get 10%, okay, or full score. But unfortunately, I feel maybe perhaps you don't remember or you didn't prepare well enough, then you get like some score, fewer than the full score, because pretty much the quiz is like I tell you, like give me kind of the score. So I think you should strive for a full score and get it, like a whatever the score all this, so that I mean when come to other activities such as assignment, written assignment or programming assignment, then I mean some of those may be a little harder. So in that case, I mean if you get full score or the quiz, which is, if I not mistaken, is 65% total. Okay, but one thing that let me bring, I mean, into the full screen here. Okay. One thing that I would like to highlight is there are there are 5 or 6 people missed doing this quiz. All right, so I don't know why. So if some of you guys have some issue in terms of connectivities or your computer and all those, I mean, let me know. I'll try to do something, but I mean, the quiz should. I mean, I hope that everyone should do the quiz because the main reason that I kind of throw away the exam and having the quiz instead, because the quiz, I think, two birds in one shot. One is some sort of politely force you to review what you have studied, and secondly, and then I mean, uh, it's easy score that you should have. Secondly, it allowed me to see how did you learn from the class, because pretty much most question I ask, okay, uh, it would be something that I think is important. There are so many topic that I can ask you, but then I try to pick something that more kind of popular or important, okay. Let's see, Jake talked about the internet was going in and out for past couple weeks, so it's getting better. So if any of you guys have not done the quiz, okay, I'll give you maybe one forgiveness that contacted me, okay, directly, and then I'll open the quiz, let someone who has missed the quiz doing the quiz. All right. So just hang on and work with me. I'm motivated to get you, I mean, the best learning experience. And also I know that most of you guys expect good scoring, but then you have to put the effort there. You have to monitor whatever activities on Moodle. So I'm trying to post all possible important thing on Moodle and give you convenient to access all material, but also you should review and then do your job, which is, I mean, at this point, is a quiz. So by perhaps this Thursday, I can have another quiz on lecture 3 and 5. Okay, but then 5 is more. There are more activities that it require you to do some writing. So I may add one more written assignment. Okay, which I think you have one more week. The due date is one more week. But however, the quiz probably will the deadline would be on Sunday midnight, and it's gonna be time for 20 minutes. Okay, let's see. Okay, I'll make sure that I'll send email. Okay, all right. So I think someone just mentioned that. I think someone who missed the quiz will work on that. Okay, all right. Now coming to this term paper, if you guys have read the description that I post on Moodle, okay, I think this is just summary from that description. My expectation that, I mean, first you have to choose the term paper topics, because without term paper topics you can study and then start working on the report, and then the report, I don't ask you to write a whatever written report in those details, but then capture it, okay, in PowerPoint or presentation form. Okay, so you could post. I think I expect you either to have PDF or the PowerPoint file around 10 plus minus pages to summarize what you study. Okay, next slide I'm gonna talk about some outline of your presentation in generic form. Okay, the due date of this PowerPoint presentation, okay, is gonna be on April 28th. Okay, so I think you have to submit because I think I create assignment kind of item, so then you can submit online by 28th. So every one of you guys, I will post once I have this, I will put all presentation into my Google Drive or Dropbox and then provide you the link so everyone could access your PowerPoint. Why? Because um, from after the due date, I will schedule everyone. Then you can have a chance to do online presentation via Zoom. Okay. Initially, I ask you to post on YouTube, but then YouTube, we can't ask you live questions. So in that case, I think last week I have some good experience using Zoom conference, video conference call or tools. Okay, you can also record those sessions. So in that case, if you guys do presentation, I could ask, or your colleague could ask some question, and I see that asking question during live presentation is one way, one effective learning or stimulate more thought. Okay, because a lot of time when you guys present something, I may interrupt or wait until I have a chance, and then I'll ask some question that it may connect to the material that we cover in this class. Okay, and then the Zoom would allow us to record those sessions, and later on I can post on YouTube, so that for someone who may have some issue accessing during that time or during live presentation, you can later on review those presentation as well, because some of the later written assignment I might ask question regarding something in your presentation, and then connect to some of the chapter that we cover. So at some point I will schedule your time slot, okay, for the presentation, and I expect that the presentation gonna start around end of the month, April 28th. I think someone just asked another question, Jack. So our presentation should not be, no, I think I don't expect you to write a term paper form, okay, just PowerPoint, that should be enough, because the written whatever the written report, which is good, but then I thought that how many of you guys would go and read, okay, but a lot of time if you capture the main theme in your presentation, I think that all we need. But I think for anyone who do research, you should know more detail. So in that case, when I ask some question, you should be able to answer. However, Jack, I think next slide gonna talk about the outline of presentation. One thing that I would like you to include at the end of your presentation is references. Okay, so that if any of you guys would like to know more detail, for example, someone work on Docker, and then someone want to deep dive into more detail, then your references would allow them to go and read more detail. Okay, so I think so the first presentation is expect around April 28th, okay, around 8 a.m. um, I believe that some of you guys might have used Zoom in other class, right? Okay, so if you guys need any training, let me know. I'll post some video on YouTube regarding how to use the Zoom conference tool. All right. So any questions so far in terms of the outline? Carrie, do I answer your question? But now I would read. You guys have any question? Please feel free to type on this live chat. I'm going back and forth between my presentation. Now let's see. Um, well, possible outline for your presentation is here. Okay, you should start a little bit about the background of your title. Why? What is the problem that I think these tools are the thing that you're looking into solving it. Okay, and then present the current state of art, what will work in that areas. Okay, so if you look into Docker, not just do pure Docker only, talk about the background. I mean, why the Docker? Okay, Docker in fact is a tools. Okay, I'm giving you example because I believe that there are three people choosing Docker. Okay, and in that case, Docker is came from our implementation of the concept called container. Okay, so then you should put some background and talk about those before talking about the current state of art, and not necessarily only the Docker, but also some competitive tools. Okay, and then after that, do comparison, talk about more detail, architecture, the benefit, drawback, and summary and reference. Okay. Another question from Carrie is more for the most part, so we are not writing paper but presentation to be. Yes, Carrie, that's correct. Okay, so no need for uh, the report, okay, in terms of the paper form, but then do presentation that should be more effective. I also will post another maybe suggestion about effective presentation. Okay, what you should do or you should not do. For example, just simply cut and paste. When you read something, trying to summarize in your own word. Also, have some diagram or picture, which I mean it tell better story. But then when you copy or if you don't draw a picture by yourself, quote the source where your paper come from. Okay. All right. So I hope I answered Carrie's question. Now, in terms of the selected topic, okay, let me show you. I think one of the most popular, two most popular title is Docker. Okay, you can see that on the left hand side is there are names of ourselves, the student in this class. So we have Jack, Steve, Matt, David, Ryan, and then on the right hand side there are topics that they have chosen. Okay, Docker probably the most popular. So I would suggest that there are some things similar to Docker. So you can talk about Docker, but also maybe compare to something else. Okay, have you guys heard about Kubernetes? Okay, which I'm gonna show you. I think in next two slides is one of the hottest, technology that related to container. Okay, and it's created and now it's open source. It's created by Google team. Okay, which I think is related to cloud computing as well. So I think that is one bird in one shot. One I think multiple bird in one shot. Okay, if you choose the right topic. Okay, another popular is called Voice OS. Okay, there are three of them: Carrick, Breeden, and Jake or Jacob. Okay, in that case, I hope that maybe you talk something slightly different, or maybe if you guys, initially choose a certain topic. Once you start do some reading, okay, maybe if you want to pivot to different other topics or something related, let me know. For example, voice OS probably related to UI or user interface. Maybe some of you guys may want to talk more about user interface background and also compare to other type of user interface. For example, we already cover command line and we all familiar with graphic user interface, mouse and whatever the screen kind of things. But also there are some gauge, using hand gauge and also different other UI. Okay, so I think these are. So I thanks everyone who has sent me the topic. Okay, and also I have also have post. Okay, by the way, this is Kubernetes that I told you about. Now it's one of the hot technology with respect to something related to our class. Okay, it's an open source system that help automate deployment, scaling, especially those cloud. And in fact, a lot of cloud provider using this tool for those AI platform or machine learning. Okay, so if someone choosing Docker, you might want to start do some reading on Kubernetes as well, which is quite good. So send me if you want to change any topic, please you can resend me the email and then I can update the list. Okay, or someone who consider to do voice OS, you should also consider other UI just like Gauge using hand or maybe somehow you may want to also choose the security aspect that connect to operating systems such as like those biometric, the thumbprint, the retina, and different other things. Okay, for someone who has not choose your topic, these are potential topics that you can choose. I already post this on Moodle. Okay, so by this Friday, if someone who has not sent me your topics, okay, I will randomly pick from this list for you. Okay, so I'm giving you a chance to make your own decision. Okay, in order to choose your own topic. But if you still have not have, whatever the idea to figure it out, randomly choose anything. You should not be spoon feeding you. There are things that quite interesting. For example, What about wearable watch OS? What about the disaster recovery? I mean, the replication and disaster recovery. Okay, um, and things like interprocess communication, quantum computing. I mean, look into the OS aspect on talk about quantum computing and see or search for aspect of runtime or how quantum computing would be deployed and used. Okay. Other interesting topic like DRBD, okay, like, that are disaster recovery database, various thin server like Chrome OS or Fire OS. Okay, so these are potential topics that for someone who has not chosen, please do so. All right. Anything else? All right. So this is what I want to talk about and encourage you to get it on, because otherwise, I mean, if you have not choose your topic, then you would not be able to start studying and then meeting the deadline. I don't want you to wait until the last minute. Okay. Someone has asked, Ronco talk about watch OS as watch that tell me time. Yes. Uh-huh. Yes, like iWatch or the Android on Samsung watch. Okay, so compare some of those, study some of those. I think it's quite interesting. In fact, watch OS like iWatch or Apple Watch, it also integrate with Siri. Okay, so in that case, it's also you can do the voice command as well. All right, so let's get on the topics or the material in the class, okay? Let me do a quick recap. In the past week, we have covered a management concept. In fact, we deep dive into data structure in which process can be managed, such as PCB, which is this one, and this is the PCB. And then I mean, beside PCB, that data structure that store important process information, the process memory footprint also quite crucial in order for your application to be load and then execute or store in this process. There's another question. I think he means Apple Watch or smartwatch. Yes. Thank you, Raven. Okay, so um, yes, it is. Okay, correct. Is as in the watch. That tell. Yes, that's correct. Also, the once we have process, a lot of time, in the current or modern system, your system may not necessarily run only single application or single process. So in that case, you have multiple tasks, multiple processing, multiple whatever application running. Therefore, operating system must have ability to um, perform context switching, meaning switching process to run on CPU, switch it out either to waiting state or go back to the ready state again. Okay, those we call context switching, which is mechanism in which operating system switch in and out process to and from various state. Okay, and to and from many resources on the system. Which is quite important feature in today our modern operating system, and I predict in the future as well. Um, so I'm not gonna get into this detail because this is just a capture. And then after we talk about process management concept, okay, including process creation, process termination, and then we lightly or touch upon process communication, but we kind of delay and then switch over to chapter 5, talk about process scheduling. Okay, once you have many application running, some application may be scheduled to run at certain time. Most application nowadays you want to schedule and run right away. Okay, so therefore in terms of scheduling, you have long-term scheduling, which is job scheduling, admit job to the system, whether those jobs are immediate job or scheduled job. Okay, also once if those jobs are immediate job or ready to be executed, is going to be handled by CPU or process scheduling, okay, which we call, another term is short-term scheduling. And then we touch upon a various algorithm. It's not all algorithm that out there, but then we choose only the classic one that we could contrast the pros and cons among those things. Okay, because I think what we're trying to do is just motivate you that it depends on your workload as well as the characteristic of your system, so that once you have policy which you want to achieve, because if you want to perform scheduling, you must have some criteria in which what you want to achieve. Okay, sometimes you may have multiple objective, or sometimes you may have main objective such as CPU utilization, um, throughput, turnaround time, wait time, or whatnot. Some of these criteria, some of them you may want to maximize, some of them you may want to minimize. Okay, and then we look into particular scheduling such as first come first serve or regular queuing. Okay, and then after that, we start notice that certain situation, for example, if the job that in front has very long running, or we call CPU burst, if we slightly adjust the sequence in which they execute, we may achieve significantly improvement. For example, if we want to achieve wait time or the shortest possible wait time, um, applying the shortest job first kind of priority scheduling, we might be able to achieve much better outcome. Okay, and then there are two flavor of shortest job first mechanism that we discussed. Okay, such as the non-preemptive one, which is the shortest job first. The non-preemptive one, once we schedule the job to run, then we let the job to complete by itself. However, we have a slightly enhancement from the shortest job first, we call the shortest remaining job first. Okay, in which we also compare the new arrival job versus the current job that run. If the remaining time is larger than the new arrival job, then this adjustment or this enhancement will let the shortest remaining job, okay, to be executed, and then take away CPU from the current job. Okay, so I think we show, in fact, the way that we can prove which one is better. Manually, we can do through this Gantt chart. Okay, but then you can write some program and then create data structure and aggregate all these numbers so that you can compare the result between or among various techniques. Okay, last but not least, the main classic scheduling algorithm that we study, we call round robin. Okay, which an algorithm that looks similar to first come first serve, but then we do preemptive by given the time slide or the time slot on CPU, we call time quantum. Okay, which if given this process to execute on CPU, if it can finish within this time quantum, then that's fine. If it does not finish in this time quantum, we're gonna take away CPU and put this process back to the ready queue again. That we call round robin. Okay, so the name just suggests very clearly. And then I think we wrap up chapter 5 with the real time, which we have two type of real time. One we call hard real time, which is typical real time. The main focus of real time is guarantee the completion time or execution time of that given process. And then we slightly talk about, or I think we compare with the soft real time. Okay, so that what we have covered so far. Okay, also, I think one of the lecture last week, I also touched upon the textual introduction. So in that case, I want to get started. Okay, I want to get you guys start as early as possible. If you have question, ask me. At some point, I'm gonna go back to that textual again and provide you more detail. The reason why I paused there because some of you guys might already have some good background that you can do it by yourself, okay, based on those description. If some of you guys need help, I'll provide you help. But then, however, the due date of that texture is toward the end of this quarter, I will have another programming assignment due in between. So therefore, I want to just kind of keep on going so that I can reach to that material and then give you another assignment first. Okay, so hang on with me if you guys um, want to know more detail on the texture, especially someone who has not has 222 with me. Um, we can talk, I mean, offline, or you can just send me requests. I may just have another session, maybe perhaps using a Zoom or easier to to communicate. Then you can ask me live question. Okay, but I just want to reserve our regular time and cover the main material because I want to be sensitive to a lot of you guys. I think I look at the hand raising at the first class when I asked, more than half of the class has taken 222 with me. So I want to be kind of, don't want to waste those people time. But then yet I still concerned about someone who has not enough background because at the end of this quarter, I want everyone to have equal kind of knowledge or capable. Okay. All right. So the last topic on this lecture 3 or chapter 3, I'm gonna talk about IPC. Okay, so hang on, what is IPC mean? So we're gonna go into those details. So let's start with some motivation. Okay, my question I think would be based on this. My motivation probably would be based on this question: why multi-processing or multitasking? Okay, or multi-thread program system is important. Well, because currently, there are a lot of high demand in terms of using computer to solve the problem. And sometimes you may have multiple tasks or multiple applications running on the same system. Some of those tasks or process, okay, or the thread that you're running on the same system. Sometimes they may just run independently, that by themselves, but sometimes some of them they may want to exchange the information. Okay, so in that case, I mean, if you have multiple processes, two applications, they want to communicate. So there must be way for communication. Okay, so therefore we're gonna go and talk about the concept of interprocess communication uh, um, in this lecture. Okay, so I think that is some motivation. As I mean, that question, in fact, I posed before the multi-core or multi-core or multi-CPU is quite popular because I touch operating systems since early 2000, and then if you all go Google, you know that multi-core start getting more popular around 2005, 6, or approach to 2010 there. Okay, so even though I think even though we have single core, single CPU, multitasking is still important. Okay, because multitasking concept is not new. In fact, it's been there for almost 20 or 30 years there. Sometimes not all application would want to occupy CPU. Some application may want to access I/O. So in that case, once application access I/O, CPU is free. So therefore, multitasking is still very useful. But then with multi-tier, multi-core type of architectures, okay, it even the need even heighten. Okay, amplify maybe 10 more times because you have much more resources. Okay, in a way that you can run multiple applications, and some of those systems you have multiple applications communicate in concert way. Okay, that's what this multi-core, you can create multi-core system and create a building block toward multi-tier type of architecture. um, Most of you guys, we all nowadays application that we are using is multi-tier architecture. In fact, you guys are browsing YouTube. Okay, it's also multi-tier type of architecture. Most of us using browsers, okay, or some standalone application here, okay, that communicate to the middle tier. okay, which is it could be web server, video server, or different type of server, okay. And then back end from this multi-tier or middle tier architecture, you may have a database tier that store the data. For example, when I log into YouTube before I do this live broadcast, okay, then I have to use the application log into the middle tier, and then it look up my record so that it know my the streaming channel, which one belong to me. So then I can post whatever those URL to you. And then you can get on by using your browser and then log into YouTube. So then you can watch the video. So with this, you can see that a lot of process application must run on various tier, okay, and then they must communicate. Some of the tier within that server, you may have multiple processes run within those. So it just interconnect and form larger and larger scale. So overall, this multi-tier architecture, another form or common term we call distributed computing. So most of today application or system that we use, I think it's in form of multi-tier or distributed computing. Yeah. So let's move forward. Now, let's deep dive into a given system. Within one system, you may have multiple tasks running, okay? Which mean, for example, you may have Excel maybe running with your um, maybe PowerPoint with word processor, and then you can start exchange or cut and paste all those information among those application. Okay, how those things can work? I mean, have you kind of puzzled that? How could you cut and paste from one application to another application? In fact, underlie whatever mechanism that allow this cut and paste, okay, it would be managed by operating system using certain type of intercommunication mechanism, okay, which we call IPC. So for example, let's take a look at this situation. You have P1 and P2. P1 may be Excel, and then P2 may be your PowerPoint, PPT. So in this case, let's say that if I want to cut from my spreadsheet, okay, and then paste into P2. So now Excel would be producer, and then P2, PPT or P2 is consumer. They interact, okay. As the user, we take it for granted because we use based on those user interface mechanism that allow us to do whatever is convenient a feature, because otherwise a lot of time if you have to write the whatever that spreadsheet into a file, okay, and then you can use another application open and include those files, that can be done too, okay. But then here we have like all on the fly that you can cut and paste. So I think what I'm trying to show you is that I try to relate the current application that or the way that we exchange information among various processes. But in fact, if we look into more detail, the underlying mechanism, there must be some sort of inter-process communication, okay? Uh, but then with this inter-process communication, you have producer and consumer. A lot of time you may have some issue. For example, if one process is faster than the others, okay, and then one process start writing messages to consumer, producer, and consumer. If you don't be careful, some of those data may get lost. Okay, so I think we'll look into the mechanism and also the issue in which how do we prevent so. Okay, now let's deep dive into before we talk about inter-process communication. So I think the situation that I mentioned to you in terms of multitasking or multiprocessing, sometimes we call cooperating processing. That means that process is program in execution, and then once you execute, they may cooperate, they may exchange the information. As you know that we touch upon in this class, process normally is independent process, okay, that normally they have their own memory footprint. There is no common share resource by default, except there are certain mechanisms that you could create and let them attach to those. So we have a term called independent process that normally cannot affect or be affected by execution on from another process. Whereas we have another situation we call cooperating process or processes that can send and receive the message. Okay, so it can affect or be affected by execution of another process. Now, the advantage of multi-processing or process cooperation is it support information sharing. Just like example I told you, cut and paste and all those kind of things. Computational speed up. Let's say if you want to improve performance, things start running slowly. Okay, then you buy uh, more faster CPU or more CPU, more cores there. But then if you just run single process, even though you have multiple core, multiple CPU, you will not take advantage. So therefore, you must divide, that process into subtasks and then run on different processes. So therefore, that also suggests cooperating processes, improve performance, improve the speed up. Also, in terms of software engineering, you could divide, the task so that you can write some modules. Okay, so in that case it make the development more simplified, modular kind of design. So it's that modularity. And also it provide you a convenient, not only in terms of writing the program, develop, the code, but also during the deployment, during the upgrade. Imagine that if you have one gigantic system, okay, that does everything in single process. If you want to upgrade, you have to bring down the whole process, right? But then if you subdivide, that big system into subsystems, smaller tasks or modules, you can simply swap out one module with another modules, because if they run on different processes, so in that case, all the process can be up and running. So it provides you convenient programming as well as deployment or upgrade. Last but not least, this cooperating processes or process cooperation is also very suitable for multi-core architecture. Why? Because you have more cores. Why not running more processes there? Okay, all right. So I think that is a motivation before we lead to inter-process communication, because once we start having multitask, then we have to look into how do they communicate. Okay, what are mechanisms, what are pros and cons among those inter-process communication mechanism. Okay, so I think that's what we're going to talk about, inter-process communication. You guys remember this term, okay, which in industry they're going to use this term, so don't be surprised or puzzled when they talk about IPC. Okay, especially in term of in industry, when you start talking about multitasking, that means inter-process communication. Okay, is a mechanism for which processes used to communicate and synchronize that action. It's not only, the important aspect is not only communicate, but also synchronize, because once you have multiple processes to communicate, okay, sometimes synchronization is quite crucial, because otherwise, if you don't do synchronization, let's say one process already write two messages to the consumer process, but consumer process have not seen the first one because we don't do synchronization. So therefore, you're gonna lose the first message. And then if that message is quite crucial, for example, is that message happen to be your transaction in which you just deposit money in ATM machine. Would you like to that thing to happen? Probably no, because you want every messages should be handled and securely safe. Okay. Um, so most message system, okay, process will communicate with each other without resourcing to share variable. A typical operation, in terms of the IPC mechanism, this is a generic form, but we're gonna deep dive and talk about certain tools or protocol that implement this IPC or inter-process communication concept. Okay, so a two common operation that inter-process communication support, one we call send. So mostly consumer will send the message, okay, which can be either fixed or variable size, okay, and then the consumer will receive the message, okay. So assuming that, let's say that we have process P and Q, where P and Q wish to communicate. So in that case, P and Q must establish communication link among them or between them, and then start exchange messages via send and receive operation. Okay, so now when we talk about this communication mechanism, uh, if we look into the implementation of this communication link, some of them could be physical, some of them could be logical. Physical could be memory or spatial memory that you designate as shared memory, or you can use hardware bus, okay, that allow this communication, a direct communication. Or you may develop something like logical kind of entity called, for example, name value pairs. Okay, then that could be some logical communication link that you establish. Okay, and then you let two process to communicate through this logical, and this logical implementation could also sit on the top of some of these physical one, for example, share memory or some bus or some sort of link mechanism or hardware link. Makes sense. So I think this is main theme or concept of interprocess communication in generic kind of ideas. Okay. Now, in order for us, let's say that if we're gonna implement such IPC mechanism, okay, or we're gonna use those IPC mechanism, we must ask ourselves or do our homework. Okay, so these are questions that we have to ask, such as how are links established? Okay, whether it's the physical or logical, or what are the syntax or format that we have to establish. Okay, can the link be associated with more than two processes or not? Sometimes the link would allow only a pair of two processes. Sometimes you may create some sort of the link that you can attach many more than two processes to that link. Okay, the third question that you might ask, okay, before you start do implementation or using this link is, how many links can there be between each pair of those communicating process? Whether it has to be one, okay, one to one, okay, among that two process, or that two process you can create multiple links. Okay, then the next question is, what is the link capacity? Okay, what is the bandwidth of those links? Would the link has some sort of the buffer mechanism as well? So those are type of questions that you have to ask. And then another question is the size of message that link can be accommodate, fixed or variable. Sometimes some protocol may force you to say that, okay, the link or the each message could be 512 bytes. Okay, but sometimes some more flexible protocol allow you to have variable size, okay, in terms of message. And last but not least, would the link is unidirection or bidirectional? Okay, so I think let's move on, and then I think I'm gonna have some example, and not an exercise, but we're gonna walk through the situation together. Okay, I think as I told you, operating system is one of the most important subject, I would say, for your career. I think once you graduate, okay, the most that you're gonna use the knowledge would be operating system for the entire life of your career. But whether specifically you may have some assignment to do certain thing, but then that certain thing, application development or whatnot, you can have to know underlying operating system. So I think without knowing operating system, it would not give you to the next level, that or the depth of the knowledge that would allow you to do better things. Okay, so trust me, before I came here, I spent close to 10 years, which is not quite long, but then with that period, I moved up quickly and significantly, and I don't want to brag here. I think when I came uh, uh, back to academic like Louisiana Tech 2002 in the department, it's just like rock star kind of, popularity, because I came from Lucent or AT&T or Bell Labs, which is similar to Google Lab today. Okay, and then I was able to attract a lot of funding, uh, both from um, federal, such as National Science Foundation, NSA, Department of Energy two times, and then beside that we have good relationship with industry such as Intel, Dell, HP, and a few other. That's my group used to have a lot of free toys to play with. That's why my previous student, most of them from my OS class, because that's the class that I taught when I came here, and be able to associate with them, and many of them become very successful in industry. Sometimes I invite some of those students to present in the class, so that it's not only I want you to learn more from that experiment, also I want to connect you with them, because I think to be able to expand your network or horizon, or your future career, know-how plus know-who is quite important, especially if you have good strong network that you work together. So I think one of my previous students is the CTO of a mid-sized healthcare that uh, he's a CTO, so he has the whole kind of company um, technology, IT type of responsibility, and report directly to CEO, and he's at um, Monroe. Okay, I think the name of that company just elude my mind. Another person, I think he's a country manager in China for Nvidia. So you can see that the whole market of Chinese market is quite large. Okay, and he take care of the whole. Um, uh, in fact, Asia Pacific. But he was in Silicon Valley many years ago when he graduated, and I think the first job he got from Dell through my connection, because I mean all you guys, I can just use my relationship, I mean, to get you the job, but I also can open the door by connecting you to someone that I know, and then all I think it have to be depending on you and your ability to demonstrate how much you know. All right, so let's move on. um, well, I think I think these are two popular communication model or interprocess communication model that I like to discuss and contrast between these two. In fact, these two type of communication, the first one we call message queue, which is A here. This is message queue. And then on the right hand side is share memory, okay? Now you can notice the slight difference. Okay, if you take a look, let's take a look at on the left hand side, model A, which is message queue first. You have process A and B running on in user mode. Okay, you can see that the kernel run underneath here. Okay, now process A and B wish to communicate through this message queue. So therefore, the message queue is being created in the kernel level. And then when A and B wish to send and receive data, then they have to access the kernel. Now, accessing the kernel, you all know how to access thing in kernel, which is a privileged resource or the resource that we must protect. So in that case, it requires system call. Okay. All right. So I'm gonna come back to this and then contrast. Okay. Now take a look on the right hand side, which is a shared memory here. The shared memory interprocess communication. You first establish a shared memory, which is in user space. But in order to create shared memory, okay, then you have to call system call, so that I mean, not all everyone freely can access or establish shared memory, because it must be protected. Okay, but once you create, okay, then you can allow process A and B attached to that shared memory. Okay, so in that case, now if A and B wish to communicate in model B, all it does, it will attach and then read and write to the shared memory, as if just like a regular user instruction. So therefore, you will reduce a lot of overhead. But then there's pros and cons in between too. Does it make sense, guys? So now let's take a look into certain example and compare between message queue on the left-hand side, which is kernel access inter-process communication, versus on the right-hand side, which is shared memory, which you just perform one system call to create this shared memory, and then A and B can attach, and then after that, you will perform regular user mode operation. Okay, so now I think before we get into those examples, let me talk about, I mean, the two category of communication. One we call direct communication, another one we call indirect communication. And then after I finish direct and indirect communication, I'm gonna go into explain the contrast between message queue on the left and the right hand side, and then compare the performance as well as other aspect. But now in terms of direct communication, okay, in this type of communication protocol, processes, okay, must name each other explicitly so that it can have a direct communication. So now you can see that we use the same operation, send and receive. Where send, you have to put a process in which you want to communicate to. So in this case, you say send a message to process P. And then to receive, you want to receive for a certain process. So you specify the sender, okay? Now you want to receive a message from process Q. Now, in terms of the properties of this direct communication link, link normally established automatically. Okay, okay, and link is associated with exactly one pair of communication process. And between each pair of these, there exists only exactly one link, as I told you. And then the link could be unidirectional or bidirectional. So these are concepts. I think there are some implementation using this direct communication based on whatever the tools that you use. Okay, and in contrast, which is indirect communication. Okay, then the message are direct and received from the mailbox. So in fact, it's just like you can think about post office. Okay, you can put posting like bulletin board. You can post your message, okay, into the mailbox or bulletin board. Maybe perhaps you specify the port ID. Okay, so in this case, you may have one producer, one whatever process that deliver the message, and then in this case you may have multiple processes read the message from this mailbox, or maybe one process depend on the certain protocol that you use, okay, within this indirect communication. So in this type of indirect communication similar to mailbox, in that case unique mailbox ID is important, so that you know which mailbox you're going to put the message or the envelope in there. Okay, now the process can communicate only if they share the same mailbox through this unique mailbox ID. In terms of the property links, the link only if the process can share common mailbox. Okay, and then the link can associate with many processes that I mentioned. Normally you have one producer and multiple reader, but then you can have multiple producer, multiple reader, but you have to ensure that they are not clobber to each other. So I mean the simpler implementation and easier to write and debug, you probably would have a unique one producer, one mailbox. Okay, but then the consumer, you can have multiple consumer to the same mailbox IDs. Okay, if you want to have another producer, then I would establish another mailbox with another unique ID. Then each pair of the process may share several communication link, and then both link could be unidirectional or bidirectional. All right, so now the notation in terms of direct communication is normally you first start create the new mailbox, okay, and then after that you can start sending receipt to the mailbox, and then afterward you would destroy the mailbox. The operation, you use the same operation, send and receive, where send you specify A, where A is unique mailbox ID, is not just whatever the process in which you want to communicate. That's why we call indirect communication. And then to receive, you want to read from which mailbox. Okay, so now this is more kind of example or situation where you start sharing some mailbox. So in this case, for example, you may have P1, P2, P3 share mailbox A, where P1 sending and P2 and P3 receiving. Now the question would be, who is getting message? So I think it's based on the protocol in which you implement this. Okay, if you may want to use round robin or this message important for both, then maybe you should have a protocol to say that the last one who will remove that message. Okay, so here the following could be potential solution. First solution is allow link to be associated with at most two processes. So I think this one is very rigid type of protocol or solution. The second is allow only one process at the time to execute the receive operation. Last potential solution is allow system to select arbitrarily the receiver and sender notify who received that was. Okay, so why don't we do this? I think we reach the midpoint. We'll take a 3 to 5 minute break. Okay, I think it's long enough and mostly it's lecture, so I think I could kind of feel that it could be a little boring. So hang on with me. I think there are some good content here. If you're listening to this, I think then your review will be much easier. Okay, so I think next I'm gonna come back to these two communication model, message queue and share memory, and start contrasting, okay, between these two. In fact, message queue, it looks similar to somewhat like a whatever indirect communication, where share memory is more direct. Okay, so yeah, when we come back, we'll talk about this and then analyze the potential, um, for example, performance factor and security reliability issue among these two models. Okay, so guys, take 3 minute breaks. Okay, we'll come back around 9:00. Right now it's 9:01. We'll come back around 9:05. All right. Okay, so we'll be right back. I'm gonna play some music. I'm gonna go get something to drink. Speaker is on. Connected. If you guys have any question, please type on the live chat. I'll come back and read and try to answer before we resume. All right, guys. Let's come back to our lecture. I think it's 9:05, and let me just shut off my music. Um, so now, guys, let's talk about these two communication model that quite or interprocess communication model that quite popular and has been used or implemented in many systems. Okay, on the left hand side we call message queue. Okay, in which just like you can think about just like mailbox. You establish mailbox like M here. Okay, let me just switch to the communication, the presentation mode. So then I can use the pointer, the pen, so then I can circle something for you. So as you see that in order to communicate using message queue, which is just like indirect communication, okay, on mailbox, you first create message queue in the kernel, okay, and then let's say that given two processes wish to communicate, then process A and B will communicate, okay, through this kernel memory. So every time it requires system call here. You guys with me so far? And you can remember, right? Whenever we perform system call, okay, then it would require context switching, which means the process that makes system call, it will transfer the control to operating system, and then that process will get suspended until the system call complete. So in that case, that process, the process information must be saved in PCB, and then you can start switching and then making the system call until system call complete. Then you wake up the process again. Okay, so those are the overhead in which one system call is being made. What is the benefit of system call? Why do we need to do so? Because we must assume that anything in kernel it must be protected, because there are common resource that a lot of process, okay, can access. If we don't control, then some process which may be ill intention or unintentionally could harmful or create some sort of chaotic situation in the system. Okay, so therefore system call is it would require more overhead but provide more secure way to access. Now compared to the shared memory on the right hand side, in this case it like more toward like direct communication, okay, or similar. It may not be pure kind of protocol, but I think the feel or the feeling is more toward direct communication. So first you create shared memory. To create shared memory, uh, you need to use normally you have to use system call, okay, because it's something that you ask permission from the operating system to create, okay, so therefore it will require one system call to create shared memory, and then also another two system call that allow process A and B attached to the shared memory, okay. So in fact this logic I just code based on the implementation of shared memory on Linux or Unix, okay? And once you attach process A and B attached to that shared memory, just like you attach your address to a certain type of memory, okay? You gotta remember, I mean, when you start writing program in C and using address, you can use that address to point to any data or any location of the memory. Same thing as in this shared memory, okay? But this is just a space memory that common among various process. Normally, when you create memory by yourself within the process, that address or that block would only be seen that in that process. But shared memory is a spatial memory that you can create, and multiple process could attach to this shared memory. Okay, so I think now let's compare between these two techniques. Okay, and in term of let's take a look at in term of performance first. Okay, now consider these two communication model, okay, and also to make it to compare or contrast between these two communication models, we must make some assumption, okay, so that we can compare apple to apple. Let's assume that each user mode instruction would cost 1 unit, and then the system call costs 100 unit. I just make it up, it could be more than 100 or less than 100. I think the number doesn't matter, okay? But then we're gonna create a performance model in which it would allow you to start understand the impact of one techniques versus another techniques, okay? I would say whatever I'm showing you here, the concept, it could be applicable to any system in the future, that when you start designing, before you start building the system, you can do performance model in a way that you can study what if we change certain hardware or certain implementation, and then maybe perhaps some of these unit or performance unit get changed, and therefore you can calculate the result. So in that case, you can play what if analysis and design. Okay. Now, as I told you, okay, let's say that we make assumption that user mode instruction take 1 unit. System call would cost us 100 units. Okay. And now we assume that A and B wish to communicate 100,000 times. Okay. With this number, we have to calculate and compare between these two techniques. Let's say that if you're gonna pick and choose which one would be the better one, with respect to the performance, okay? So therefore, this calculation would allow us to make some decision, okay? So now let's take a look at this model A and B. This is, I'm zooming down that thing, and then I'm gonna show you each of the communication techniques, okay? Let's take a look at message queue first. In order to make to enable this type of communication between process A and B, we first must create a message queue. So as I told you, to create message queue, it would require one system call, which is 100 unit, which is this, the cost of a system call. All right, and then let's assume that we want A and B, okay, to communicate through this message queue or the mailbox. So in that case, once you create message queue, you're gonna have a unique ID of message queue to be the key, enable A and B to communicate. So A and B would use this ID to communicate 100,000 times. Okay, so therefore A write, okay, would cost which is a system call. It would cost 100 units. B read, okay, would cost another 100 units. Okay, but then A and B does each system call 100,000 times. Okay, so what would be the total cost, guys? Well, the total cost would include the creation of message queue, and then in this iteration, when we read and write 100,000 times. So that therefore the total cost would be 100, which is this creation, this is create, and then 100,000 times multiplied by 100 plus 100, okay, which is the total would be 2,100,000 units. Okay, now remember this number. Okay, now we're gonna contrast and compare to shared memory, how shared memory works. Okay, normally shared memory, how it works, first we have to create shared memory or reserve shared memory. So to create shared memory, we have to perform one system call. It requires 100 units. Okay, then A and B wish to use shared memory as a direct communication. So therefore, A and B attached to the shared memory. So it requires 100 units each of that attachment. This is just like you assign the address or the pointer in program A, okay, into this shared memory. And in that case, I mean, you cannot just simply attach because it's in your own memory. You have to require system call, using system call through kernel in order to attach. Okay, so it will require 100 units. Once you attach, okay, then you can simply read and write 100,000 times. So therefore, within 100,000, I think I have one zero extra, so it's 100,000, not 1,000,000. Okay, that must be the same 100,000. I think this is cut and paste kind of thing. So the cost of now read and write to the shared memory. Once you attach to the shared memory, just like you have assigned a pointer or address to whatever the data block. Okay, then you can just simply use regular user operation. If you assign as a, you can do star a, okay, which is user instruction. This is not system call, this is user, I'm sorry, this is a mistake, so this is user, I will update, okay. User operation cost 1 unit, okay. And then be read, once you attach, then it's also user operation, which is 1 unit, okay. And you know that why this is mistake, because when I write on, when I work on whatever this example on the left hand side, I just cut and paste, okay. So therefore I forgot to update, from sys to user. Now the total calculation or the cost of the share memory access, which is perform the same thing, okay, then it would be 300, okay, which is 100, 200, and 300 here, plus 100,000 times multiplied by 1 plus 1, which is 2. So the total would be 200,000 and 300 unit time. And you can see that if you do a large operation, which is a lot of iteration, like 100,000 times, sometimes one techniques, okay, may give or perform much better than other techniques. But that's nothing for free. Why wouldn't people always choose share memory? Well, I mean, if you develop an application in the sandbox, which you have secure whatever environment. Therefore, using share memory probably would be the best way to go. Okay, just like in the past, I remember when I was a solution architect for AT&T or Lucent, we have used. I think you all know Oracle database. Okay, in fact, if you deep dive into how internal Oracle work, internal has P server, S server, various server within that database system. When you perform query, it's gonna start performing the query for you. In fact, anytime when we install Oracle, I think instruction in the past suggest us that we have to create or allocate enough share memory for those Oracle database server. And our system, in fact, is in a telecom server in a secure environment. So therefore, we would not have major concern on the share memory, because as I told you, share memory is in user space. Um, Chances are that if you put important data there, if someone know that memory location address, they can manipulate or take a look into those memory address as well. All right, so that is the exercise to show you pros and cons between master's queue and share memory, which is the implementation, for example, in Linux type of system for indirect versus direct communication. So the pros and cons between kernel type of master's queue versus share memory. Share memory is could be very less cost, very fast, better perform. Okay, versus master's queue is more control, more secure, because you have to use system call every time when you want to read and write. Okay, so I think pick and choose. If you are using in implement system that not highly secure, you might want to choose master's queue so that you have more control and secure access. Okay, all right, so I hope this exercise motivate you or show you the contrast, the comparison between two techniques. Okay, I don't expect you to remember, but I also hope that you learn the concept and then can apply to any type of situation. I think once you start understand the physical problem, the how your system work. In fact, you can build the system logically before you actually spend time and money build the actual system. So you can build this we call analytical or performance model. In fact, analytical modeling is just like mathematical model that you try to represent the behavior of the system in which you want to choose or you are designing with or you're making decision. In that way, it allows you to compare before you actually make decision to invest time and money and build them. Okay. Um, so let me switch gear, and I think I'm hope to wrap up this chapter 5 before I'm going back to lecture 4 or chapter 4 on thread or multi-thread, because they're all related. And once we finish multi-thread, um, multi-thread kind of lecture. Soon later, I would assign you another programming assignment, which I hope maybe 2 weeks or week and a half from now. Now, when we try to enable inter-process communication or cooperating processes, okay, a lot of time we have the model that we have producer and consumer, okay, where producer will do any work and then the result will send to the receiver. So you have a process like P1 and P2, where P1 and P2 may, may play a role of producer and consumers. Okay. Now, if in the perfect world, okay, they are in the same speed, okay, then I mean, you may not have some issue. However, in the real world situation, sometimes you cannot predict the performance or the capability of two application or two processes. So they may be one slower, one may be faster. So therefore, you have to consider the synchronization mechanism in which when you send and receive, you want to make sure that your message is delivered there, or the mass, and or maybe in some case that you don't want to wait because you have other thing to do, so you want to send and then move on. So therefore, typical interprocess communication, okay, you may have a synchronization mechanism we call blocking or non-blocking, okay, where blocking considered as synchronous, okay, where when you start sending, the blocking send is that the sender is blocked until the message is received. Okay, so you need to ensure this is just a situation where you want to ensure that message is safely delivered to the receiver. Whereas you have blocking receive, in this situation, the receiver will get blocked until the message is available. Okay. Now, when you contrast between synchronous send or communication or blocking communication versus non-blocking, I think another term called asynchronous communication. A lot of time, asynchronous communication or non-blocking is will involve with the buffering. Okay, meaning that you have temporary kind of buffer or queue that you could save that messages, okay, so that it will not get lost. Because in terms of asynchronous non-blocking send, the sender after it's sent, it will continue on. Okay, so in this case, how do you know that the message will be safely delivered? Okay, there are certain protocol you have to use. Sometimes you may want to use notification later on if you want to ensure that the message will be safely delivered. Okay, and then when you contrast with non-blocking receive, the receiver receive the valid message, or if not, if it's not, then it no, and then continue on. So then in that situation, it can continue on and not getting blocked. Okay, so that's pros and cons versus between synchronous and asynchronous. Okay, therefore, a lot of time the synchronous communication, it probably does not require the buffering techniques, because the sender would have to wait until receiver are able or is able to receive the message. In case of asynchronous operation or send and receive, okay, it requires some buffering. So in terms of buffering, there are a few implementation or models that um, one can choose. The first one we call zero capacity. That means we have no buffer at all. So in that case, sender or receiver must wait. Okay, we call rendezvous. Okay, second type of buffering we call bounded buffer, where we have finite number of messages. Like for example, 10 item or 10 message that it has capability. So in that case, the sender will keep sending the message until the buffer is full. And once the buffer is full, then the sender will have to wait. Okay, versus the receiver, if the buffer is empty, then either it's blocked until the buffer has some item, or it continue on and then come back to check the buffer again. Now the last buffering techniques we call unbounded capacity, which in the real world there's no such thing. How could you guarantee that you have indefinite buffer or size of buffer? But in the real world, if you engineer large enough buffer that you never reach to whatever that buffer limit, what the maximum number of buffer size, then you can consider as unbounded buffer because you will never reach such situation. Okay, so in reality, there's no such thing we call unbounded capacity or infinite length. Okay, but then sometimes we can engineer large enough that we will never reach it. So it looks similar to unbounded capacity. In that case, you don't have to have logic because in different buffering kind of model here, zero capacity, bounded capacity, or unbounded capacity, it will enforce the logic in which you have to implement sender or receiver. Whereas the zero capacity, sender or receiver must use synchronous operation. It has to wait until receiver receive. For unbounded buffer or for bounded buffer, you have to check whether the buffer is full or the buffer is empty. Okay. Last but not least, unbounded capacity. In that case, let it fly. So in that case, situation in which you want to gain the performance, maybe you would engineer large enough buffer, but then once a while you need to monitor in terms of whether the buffer is kind of clogged up or not. Okay, so I think this is some idea that I want to mention and connect it to the real world type of application. Okay, so these are not a direct operating system, but something that operating system support. But then, in the future, as the programmer, some of these buffering model you have to understand before you start implement multitasking type of system where they're gonna send and receive messages. So I hope it makes sense to you. All right. So I think this picture just show a bounded buffer where you have producer and consumer, and then the producer gonna keep writing to the next item until to the end. Okay, and then once it end, then it may just go back. Okay, we call circular buffer here. Now, if consumer will start reading, if the buffer is empty, either consumer is wait or go to do continue to do something else. So let's take a look at potential issue in producer and consumer. This paradigm is quite popular, okay, in terms of cooperating processing, where the producer produce information, and the consumer consume those information or messages, okay. So here, normal situation when you have producer and consumer, we want to look to see whether it's unbounded buffer or bounded buffer. Unbounded buffer, so you have practically no limit size of the buffer, or maybe you have large enough that you don't have to concern. So in that case, you would not spend more time to check whether it's full or empty. Okay. Whereas unbounded buffer, you have fixed size of buffer size. Okay. So let's take a look at some pseudo code. Okay, let's say that you are the developer who will write your system that you have to process it or application that wish to send and receive using this shared memory or bounded buffer. So let's say that you have buffer size as 10. In fact, if you guys remember C structure, when you have chop file defined, okay, this is a symbolic constant that the preprocessor will remember the keyword buffer size equal to 10, and then during preprocessor it will replace all the keyword buffer size with whatever this value, and then the second pass of compiler will actually compile, check the syntax, and then create the executable code for you. Okay, in this case, I think we just give example code to show how do we define buffer. And in fact, that buffer could be just simple data structure like integer, or it could be a record or structure. In this case, we define record called item, which is a struct, okay, which could have multiple element here. Okay, it could be any type of valid C data structure here. So therefore, now we can define or declare buffer as an array of this buffer size item. If when we compile, we define equal to 10, it's going to be 10. Okay, and then we have in and out as the index, showing the current item that the consumer has written, or the current item that the producer is written, also the out showing the current item that the consumer is reading. Okay, now I think the next picture or the next slide will show you that the solution that I'm showing you is correct most of the time. Okay, but assuming that if you have only two processes, but then if you have more than two processes, there might be some issue that we have to do extra things. Okay, example of producer and consumer with bounded buffer could look like this. Okay, let's say that the producer in this infinite loop. Okay, all it does, the producer is gonna keep producing some item. Okay, and then store in this buffer. Okay, whereas consumer, okay, it will, all it does is just start reading the messages or the item from the buffer. Okay, now let's take a look at this producer producing loop here. Now it check first. I mean, you know this while one. While one, that mean it just keep doing infinitely. Okay, and then maybe perhaps with certain situation or certain event, you can break out. Okay, let's say that you want to terminate. Maybe perhaps you check the flag or something, and then you can just say break and then go out from this while loop. Okay. Now take a look at this red. We call while another nested loop here. While counter equal to buffer size. That means if the counter, the item that has been written equal to buffer size, that means the buffer is full. If the buffer is full, then it do nothing. It keeps spinning here. We call busy waiting. Okay, until the counter is not equal to buffer size, then it will continue on and start producing the next item. Now the next item we say buffer in, where remember in, we define in as the index that point to the current produced item. So therefore we assign to next produced item, and then we update in equal to in plus one mod by buffer size. You guys remember uh, mod operation? This is just a circular. Normally when you develop or write a circular queue, and once you start reaching to the maximum size, then you want to recycle back to the front of the queue again. Then you use this mod operation. Okay, and then once you start produce that item, then you can do count plus plus. But let me go back to the previous decoration. I think I forgot to mention about counter, or you should have counter here. Counter. Yeah, I think I missed it. I think you also have another important uh, counter, and then you define as integer. Okay, initially you may just put 0 here. Okay, so that, I mean, your code will correct in the next page. Make sense? Okay, let's move forward. So I think I already explained on producer. I think producer will wait if the buffer is full. Initially counter is equal to 0, so therefore counter is not equal to buffer size, then it keep producing and then keep update counter. Okay, until if consumer has not read it, at some point the counter is equal to buffer size, it's gonna stop there. Okay, otherwise, now take a look on the right hand side, which is consumer process. Consumer process, it declared the next consume equal to item, which is whatever item, the item that you want to assign data or information from the buffer. Now, oppositely, you can see that y counter equal to 0. That means for consumer, the condition in which when the buffer is empty, then it do nothing. Okay, so in this case, our logic, we define that when there's nothing there, then consumer just do nothing. So therefore, it just do nothing here. Spin in this, we call busy waiting loop. Otherwise, if counter is not equal to 0, okay, then next consume equal to buffer and out. Okay, now notice out and in here. As I told you, in is the index in which the producer used to keep track the current item in the buffer. Out is for consumer, that which item that the consumer has currently read it. Okay, so therefore it use buffer out here. Now after you already read the item assigned to the next consume, then you do out equal to out plus one. So you want to update the index in which the consumer is reading, okay? And then mod or mod buffer size. So that means circular kind of queue again, okay? If it reach to the end, then the mod will go back to the the lowest index again, and then you do counter plus plus. So you can see that producer and consumer do things opposite. Producer will keep producing, but this logic and this pseudocode prove to be correct if you have only one producer and consumer. You have more than this, it may not be correct, because in that case you have to do some sort of more sophisticated synchronization. Does it make sense? I just want to show you some feel how producer and consumer work and how do they communicate. In which right now we talk about, I mean here in terms of asynchronous communication where you need to introduce buffer. And in this case, remember we talk about buffer three models: zero capacity, bounded buffer, and unbounded buffer. The bounded buffer is the only one that we must check, okay, the condition in which whether the buffer is full or the buffer is empty, and then do things accordingly. I hope you guys get some point on this, okay? So let's just move on. As I mentioned to you, okay, all we talk about here so far we call inter-process communication, IPC, which is the communication that enable within single node, within single system. Okay, so within your system, you could use, for example, in Linux or Unix, you can use share memory or master queue or read and write to a files. Okay, however, if you start your application spread about distributed system, okay, then you have to use other type of communication protocol, not inter-process communication. So this one you must distinguish between inter-process communication, that the communication that can be achieved within single node or single system. When you go across the node, okay, like which I show you multi-tier type of architecture, processing or task communicate across more than two systems. So you have application A running on system A, and then application B run on maybe system number two. Okay, some of the most popular protocol would be TCP/IP or socket. Okay, have you guys heard about socket? Socket. Okay, socket. Socket communication is a low-level internet protocol that you can specify IP address, okay, and then the port in which you want to communicate. A lot of popular uh, internet applications such as mail, FTP file transfer, web server, and all those, okay, using some sort of underlie this TCP protocol, even though the web server use HTTP, but then also have to mostly rely on TCP/IP. And most TCP/IP also some application has to specify the port. For example, the email server is probably, if I'm not mistaken, there are certain well-reserved port, okay, that your application should not use them. For example, the port 21, port 25. I don't remember exactly, but some of those probably used for the email or FTP system. Okay. Also for web server, a lot of them use port 8080 or port 8000. Okay. So some of those ports would require in additional to the IP address. Okay. So the contrast between inter-process communication, communication that enable within one system. Okay, such as share memory, master queue using file. And then when you start having multiple applications that deploy on multi-tier type of architecture, which is in the form of distributed computing, which communication will go across the machine. Then you use protocols such as TCP/IP, HTTP, IOP protocol. There are a lot of protocol, WSDO. So I think some of those, I think this is beyond this class. If you are taking distributed and cloud computing, some of those protocol or things should be touched upon there. Okay, networking. I'm not sure whether you instructor in networking touch upon this or not. Okay, but they all related to operating system. Now, I think this is showing you across the machine communication. Let's say that the orange box represent a machine, okay, and then whatever ellipse here or the ellipse here represent a process that deploy. You may have one or more processes here, okay, and then the processes may communicate among each other here, okay. But now, if you communicate across the machine here, you invoke and get result. Normally, you will use the internet protocol such as HTTP or TCP/IP. But then, if you have processes within the system, it normally use inter-process communication. Why? In fact, inter-process communication is more nimble or less overhead than when you do process communication across the machine, because when you send over the network, not only, I mean, normally when you do IPC, all you need to know is just like which process you want to communicate with within that system, or what is the mailbox ID. But now when you start sending things across the machine, imagine that if system A and system B running on different operating system, then you have to make sure that the protocol has to align the bits or the byte, the block in certain format or syntax. We call envelope. And then you have little Indian and big Indian. If you guys kind of are interested in this, little Indian or big Indian is not just like the native people, but is a data format in which it ensure the compatibility between heterogeneous system. Okay, so in that case, when you do communication across the machine, it will be much more overhead. Okay, but then I think you need to balance and engineer enough that when you start distributed the workload there, okay, it will the benefit that you gain, it will ensure that it will outweigh all this overhead. Okay, so I think this picture just show you the client and server architecture that commonly we seen in multi-tier or in web type of application where your client could be the direct app or your browser communicate to the server could maybe communicate within the server within the system or communicate to the server with another system. Okay, and then this one showing you peer-to-peer, which is instead of your application act as the client, that application sometimes may act as the server as well by sharing information as the peer. So in this case, in terms of the file sharing application that you have seen in the past, like BitTorrent and all those, I think it's follow this peer-to-peer, but still in distributed system. Okay. Um, as I told you, in terms of communication across the machine, when you use TCP/IP, then you would have the IP address of each of the node, and then you have you have certain port ID that you designate for that application to communicate and send receive via that port only. Okay, so I think this is some idea about beyond the interprocess communication when you start communicate across the machine. And this diagram showing you with the perspective of operating system. I think that's why I try to connect the idea of interprocess communication with this distributed system. So you have machine A, machine 1 and machine 2, and then you run either the same OS or different OS, have some application running multi-thread communication. When you go across the machine, then you have some middleware. Okay, where that middleware, you have applications sitting on the top of the middleware, so that the developer could simply send and receive message across the machine. Sometimes the clever implementation of whatever the development of this across the machine or inter-process communication, because it depends on how do you deploy your application. If you deploy your application within single node, let's say that initially your business not very large, doesn't have a lot of user, you may start deploy only single node, okay? But then once you start acquire more user, and then the capacity of given node may not be enough, then you can go across the machine. So initially, if you have single node here, you may not want to have two implementation, because as I told you, when you communicate among processes within single system, you may want to use IPC, which is inter-process communication. Is less overhead, okay? But then if you want to do across the machine, you cannot use IPC. So therefore, you have to use socket or HTTP. But the clever implementation through this middleware, it aware of whether it's single node or across the node. So it gives you a high level layer that doesn't matter whether you deploy on single node or across node. It will map the low level implementation. If it do deploy your application within single node, then it will make use of IPC instead of TCP IP, which is much more overhead. Okay, does it make sense, guys? Okay, so I think this is some idea that I want to mention. In terms of client and server communication, okay, besides socket that I mentioned, using IP address with the port ID, then Sun Microsystem introduced remote procedure call or RPC, the short name, okay, or you have remote invocation through Java, okay, or maybe COBA, which is Common Object Request Broker Architecture, which is object-oriented distributed communication, okay. And last but not least is the web services, okay. Um, why don't we do this? Okay, I think we have around 2 or 3 minutes left here. I don't want to rush through because we have quite a bit information here. So let's pause at this point, okay? Why don't I do this? Let me continue on and finish the whole lecture so that I think just bear with me. I think you can just continue listening, or you can come back and listening, and then maybe in the next class I can take a little shorter kind of period, so that will compensate here. So just allow me to continue on because I have only 5 or 6 slides left, and I just want to make sure that we complete this lecture, so that the way to manage, okay, the live stream, it should be kind of easier for both you and me, okay. So as I told you, the socket type of communication, it requires two endpoints, where the endpoint defined by IP address and the port ID. Okay, so this is beyond across the machine, beyond the inter-process communication. Examples such as IP address is like you have this IP address and then you wish to communicate through the port 1625. And by the way, two applications that run on two different systems, you require a pair of socket that not necessary that you have to have the same port ID. It may listening to different port ID. Okay, for example, in this case, you have a client that run on this IP address on this port, but then it communicate to web server that run on port 80 on this IP address. Okay, so this is type of socket communication, okay, through this TCP IP. The RPC or remote procedure call, okay, is provide an abstraction just like normally you call function or procedure, and normally you call within your program which running on the same system. Imagine that you want to run this function on another machine, so then you can distribute the workload. So in that case, the runtime, the SDK of this RPC should allow the way to create, we call a stub, which is client-side proxy that actually act as a actual procedure, okay, on the server. So in that case, it would allow you to create or run this function, okay, across the machine by shipping the code to the target machine and run on those. So stub is just a subroutine or utility kind of modules that allow the client and server connect, okay, and then the client start locate the server and marshal mean encode the call, and then maybe perhaps the executable, depend on the implementation, okay, including the parameter, and then ship to the server. And then the server side receive the stub of this message, unpack it, and then start perform that procedure on the server. And then once it's done, then it send the result back to the client. So it look like this. I don't expect you to remember all this diagram, but this show detail how the client and server in terms of RPC send and receive, encode and decode, so that you will feel as if running this function on the same server, whereas it actually run on the remote server. Okay, so RPC created by Sun Microsystem, the same company that create Java. Okay, then if you are Java programmer, there is RMI or remote method invocation. Okay, that Java allow you to create or instantiate object on remote machine. Okay, and then that remote object will run on the remote machine on remote JVM. So you may have two JVM on the same machine or the JVM on across the machine. It's going to be the same, okay, where the Java platform or runtime will handle how this remote invocation get connected and encode or decode and execute the remote object remotely, okay. I think as I told you, marshalling parameter is encode or decode, okay. Encode, marshalling or encode the same term, okay. So I think this is example how you call server with some method, okay. This is just like object oriented, right, where you have server as an object and some method and then pass parameter. The stuff will encode and then send the method and then execute remotely, and then after it's done, then it return. Skeleton is something similar to stuff but on the server side, okay. That decode and then start execute those remote objects. So I think this is the last slide, and then I will complete. In fact, I have more lecture on Linux IPC, including dupe, share memory, and all those. You can continue reading, but when I have time, I'm gonna go back and touch upon those. So this is the last slide before I complete it. It's just a comparison among things that we discussed, like socket, RPC, RMI, Crowbar, and web services. In terms of languages support, in terms of socket, you can write in any languages, okay. And the socket you can write in Python on the client, and then server maybe C, C++, or even Java, okay. So it support multiple language. All you have to do is just open socket, read and write to socket. um, but the data type that you send through socket is quite raw. It's just a block of byte that you send. So therefore, if it's raw, then performance is quite fast. Okay, performance is good, quite performant. In terms of RPC, it support only C or C++. The data type is gonna be the procedure with parameter. Okay, so therefore it require more overhead because you have to stop and skeleton, encode and decode. Okay, same thing as RMI only support by Java. Okay, you cannot use any other languages, and the data type is remote object. Okay, as well as more overhead. Last but not least, you can Google COBA. COBA is more like distributed object, okay? So it supports multiple language. It has some sort of protocol or syntax where you can create a web services or COBA object, okay, which is remote object and execute remotely. And therefore, it's gonna have much more overhead, okay? So I'm go over around 5 minutes at this lecture. So I'm gonna stop at this point. um, if you guys have any questions, so please type me on the chat, live chat, or you can send to email. And also for someone who has not chosen your topic, I already give you a list of topics that I upload on Moodle. So take a look at assignment called term presentation, okay? And in attachment, it would include the topic that being chosen by some of your friends, and then there are some topic that there's no name in front. You can choose any topic, okay. Otherwise, have a great day, guys, and please practice social distance, stay safe, even though I think you may be strong enough that you might not impact anyone, but I mean, Sometimes you may have asymptomatic or people who show no symptom, and then when you start visiting your parent or someone, in fact, I mean there are some sad story that there's some girl, not in this country, in Thailand, that just went back to visit the parent, and then now the parent is in emergency room, and I don't know the situation. It's a kind of sad story. So stay safe, you guys, and I wish you guys have a great day. Make sure that I mean, for someone who has not done the quiz number two, contacted me, and we'll talk about it, and I'll try to address issue of whatever you guys encounter, and then enable you guys to make sure that you do all the quiz. All right, okay. So have a great day. Okay, I'll see you next time.